Okay, today we're going to learn Lesson 5.1, which is graphing quadratic functions. The new vocabulary would be, let's just go through these pretty quick. The quadratic function is a non-linear function, which we've done all lines pretty much to this point, and it can be written in the form f of x equals ax squared plus bx plus c. This is the standard form, and the quadratic term would be the ax squared term. The linear term is the bx, and the constant term is c. A parabola is the shape of the graph of a quadratic function. The axis of symmetry, it's a central line about which a parabola has symmetry. Vertex is the maximum or minimum point on a parabola. And it's written like any point, like x, y. The maximum value is the highest point on a parabola, and the minimum is the lowest point on a parabola. So a key concept of the graph of a quadratic function, when you have a function that's y equals ax squared plus bx plus c in that form, where a is not equal to 0, the y-intercept is found by plugging a 0 in for the x's, and c turns out to be your y-intercept. The equation of the axis of symmetry is x equals negative b over 2a, which is really helpful. We'll use that a lot. The x-coordinate of the vertex is actually the x value that you find in the axis of symmetry as well. And so if you look at these, here's your y-intercept. Here's your vertex. Down here it's the very lowest point, so that has a minimum. And your axis of symmetry is that vertical line that goes through the parabola. And then once you have your y-intercept, you can count how far away it is from the axis of symmetry, and then go that far the other direction, and you'll get the reflection of the y-intercept. Does your parabola open up or down? Well, if the a part that's right here, this ax squared, if the a part of your quadratic term is positive, so if a is greater than 1 or positive, it will open up. And it will have a minimum. If a is negative, or it's less than 0, I think it's negative, it will open down. And it will have a maximum. This parabola right here in our example, that one's opening up, and so it has a minimum. So let's go down and do an example. there's a step-by-step process here that Miss Brocklebank did with you guys, and it's just so good. It just helps you walk right through the process. So let's use that information that she gave you last year or last semester. Find the plot, or find and plot the y-intercept. So that's step one. So we've got our quadratic function up here. We're going to take it and we're going to plug a 0 in for every x that we see, because we can find the y-intercept whenever x is 0. That means f of 0 equals 0 minus 0 plus 6. Sorry, that looked like a 12, didn't it? Which equals 6. So my y-intercept equals 6. If I plot that, I just go on the y-axis 1, 2, 3, 4, 5, 6. Then I'm going to find and plot the vertex. Well, I'm going to find the vertex by saying x equals negative b over 2a. And that's also what I'll use for my axis of symmetry. And so the b part of this is negative 12. So negative times negative 12. And the a part of this is 3. So I plug that into those. And I get 12 over 6. And so what I'm going to get is a 2 for my x part of the vertex. So remember I said a vertex is an x and a y. So I've got the x part. And so now I'm going to find the y part by using that 2 in the original function. I'm going to say f of 2 equals 3 times 2 squared minus 12 times 2 plus 6. And that's going to give me 3 times 4, or 12, minus 24 plus 6. And so 12 minus 24 is negative 12 plus 6 would give me negative 6. That is the y part of my vertex. So I'm going to graph that point right there. I'm going to plot that point. And so I go over to 2 and down 1, 2, 3, 4, 5, 6. So that's 2, negative 6. On the axis of symmetry, like I said, I'll do exactly the same thing. I do negative 12 over 2 times 3, which is 12 over 6, which is 2. And so my axis of symmetry is actually going to be written as x equals 2. That x equals is a really important thing. That has to be written for it to be correct, because it's this vertical line at 2, at x equals 2. So that is my axis of symmetry. I'm going to plot the reflection of the y-intercept across the axis of symmetry. And so my y-intercept is 2 units away from the axis of symmetry, so I'm going to go 2 more units over, and that gives me another point. And once I do that, then I'm just connecting the dots, and I want to make sure it's kind of curvy down there at the bottom. It doesn't look like a V like my absolute value, but that is how you graph a parabola. Let's go on to the maximum or minimum value. And I was telling you a minute ago that if your A is positive, then you're going to have a parabola that opens up, and it'll have a minimum value. Well, that value is the y-coordinate of the vertex. If your A is negative, it's going to open down, and you'll have a maximum value, and that the y-coordinate of the vertex is the maximum value. So to go on, let's do example 2 very quickly, because I want to add a couple of things to that. We have a function of f of x equals negative x squared plus 2x plus 3. And it says to determine whether the function has a maximum or minimum value. So we're going to go through this process, and we're going to get to the maximum or minimum value thing right down here at the bottom in the next steps. But we're going to start by finding and plotting the y-intercept. And remember, that's when we plug in 0 for x. And that's going to give me 0 plus 0 plus 3. So 3 is my y-intercept. So I'm going to go on the y-axis up to 3, and I'm going to plot that point. Then I'm going to find and plot the vertex. Well, I'm going to do that by saying x equals negative b over 2a. And in this case, b is 2, so it's negative 2 over 2 times negative 1. So negative 2 over negative 2 equals 1. That's the x part of the vertex. I'm going to find the y part by plugging that 1 right into the function at every single x that I see. So negative 1 squared is negative 1 plus 2 plus 3. And that's going to give me positive 1 plus 3, which is 4. That's my vertex. Positive 1, and then up 1, 2, 3, 4. I'm going to find the axis of symmetry by saying x equals negative b over 2a, which I just found right up here, and I've got x equals 1. So that's my axis of symmetry, and I'm going to make this vertical line right through x equals 1, right through the vertex. Then I'm going to plot the reflection of the y-intercept, so it's 1 away from the axis of symmetry that way, so I'm going to put 1 over here as well. And then I'm connecting the dots. And so that's steps 4 and 5. Well, step 6 is asking you, does the parabola open up or down? Well, it opens down, right? And the ones that open down have a maximum value. There's my max right there. And so it says, does it have a maximum or minimum? Well, it has a max. And what we said earlier is the maximum value or the minimum value is the y value in the vertex. And my y value of the vertex is 4. So my maximum value, is y equals 4. Oh, I was sorry, I got ahead of myself. This is the answer to step 8. Maximum is the answer to step 7. And so the last thing I want to do is domain and range. So my domain is going to always be all reals because parabolas go as far left to infinity and as far right to infinity, and that's how they all are. But my range will be different than that. My range is going to be y, the set of y, such that y is either greater than and equal to or less than or equal to the y value of the vertex. So in this case, because it's going down, it's going to be less than or equal to 4. So that's how you identify the domain and range. Now when you do the homework that's on this page, I'm going to give you a worksheet that's going to have all of this just step by step worked out. And so what you're going to actually do is just go by each one of the steps, and I'll show you a picture of that. Here's a picture of the worksheet that you're going to get, and you'll write down your quadratic equation in this box, and then all the way down this column you're going to do everything it tells you to do in every one of the things on the left side. You're going to go all the way down. You'll get all the way down to where it's domain and range, and then you'll go back up and you can do a second quadratic equation here and use that column, and a third quadratic equation here and use that column. And I believe you have 6 problems, so you're going to have a couple of these pages to work with. So I think that concludes our notes, and you'll need to complete that homework that's on the front of the